Okay, good evening, ladies and gentlemen, and welcome to this Saturday live edition of our Lean Six Sigma live coaching session. And today we are going to discuss something very interesting, which is about specification limit and control limits. Okay, anybody new in the room right now? Just type me in the chat box. And first, let's welcome the new members in the community, and then we'll start the session. Okay, कोई new member है right now in the room right now attending the session first time? Just type me in the chat box. Let me see if the chat is open. I think yes, I think it is open, right? Okay, anybody new in the room? Am I audible to you guys? Just give me yes in the chat box. Just give me the confirmation. Okay, fantastic. So I got some confirmations. I thought I was not audible enough. All right, fantastic. Chalo, let's begin. I hope nobody's new in the session. The very new member, right? I think everybody has at least attended one session before that. All right, super. So today's topic we are talking about is specification and control limit. A lot of people get confused about specification limit and control limits. So that's what we are going to go deeper into the concept of specification limit and control limits. And we are going to do some exercise as well and to understand the depth of this important topic. All right. Super. Chalo. So आगे बढ़ते हैं. Let me just open my whiteboard right now. And let me just open up. Okay, how many attempts we have allowed to green belt? Oh, there is no attempt, Manojji, as such. Okay, you can give multiple attempts, but as far my knowledge is concerned, one student had given 3 attempts, maximum 3 attempts to clear the test. Okay, 95% of the people basically clear the examination within first attempt itself because it's a open book test, right? So in open book test should not be a big problem. If you are prepared well, if you have taken your notes properly. So open book test should not be, and see only 70% is required to clear the test. So only 5% require the second attempt. I remember only one person who went for the third attempt to clear this. But don't worry, you can have multiple attempts. Don't worry about it, okay? And it will not reflect in the certificate as well. Okay, chalo. So let me just quickly start my whiteboard, right? Okay. So first of all, the topic which we are discussing is very, very important for us to understand, both for green belt, black belt, both. But the basics are very, very important. Now, how many of you are aware of control and specification limits? Just type me in the chat box. Both limits. Just type me in the chat box. Everybody. How many of you are aware of control and specification limit? Okay, Suresh ji is saying me. Who else knows both limits? Only one person? हाँ जी, बाकी इसने सुना भी नहीं क्या control limit, specification limit? First time? Okay, you know specification limit, all right? But don't know control limits. Okay, who else? Who else? Who else? Who else? Nobody? Okay, chalo. So, 2 people know the limits. Okay. All right. So, Mr. Kamble also knows about it. All right. Chalo. Good, good, good. Nonetheless, we'll start from the scratch because this is a very important topic, guys. And for the new members, this topic is covered in the green belt level, in the initial. Of course, this is covered in the black belt level as well, but in the green belt level major phase, okay, in the process capability analysis, this topic is very well covered. Okay. So, green belt major phase, there is a last topic of the major phase, which is process capability analysis. You will find out this topic which we are discussing, which is specification limit and control limits, and what are the differences, what are the similarities, and what are the relationship between these two limits. Okay. Now, as I mentioned to you, we are talking about the major phase Now, when I say major phase, it applies to both green belt, black belt, both major phase. This will be applicable. Okay. Now, I'm just drawing two graphs in front of you. You need to tell me the names of the graph. Okay. Now, this is graph number 1. You need to tell me the name of the graph. Okay. First, let me draw this and then you need to tell me the names. All right. This is graph number 1 and this is graph number 2. What is the name of the graph number 1 and what is the name of graph number 2? Everybody. Right now, 1 and the name, 2 the name. Everybody type in the chat box. 1 the name and 2 the name. Put 1 dash, put the name of the graph, then put 2 dash the name of the graph. Everybody. Okay, very good. Manojji, you are fantastic. 1 histogram. Histogram कौन सा? First या second? Give the name. 1 dash the name and 2nd dash the name. Everybody, chalo, try karo. You can make the mistakes. We are allowed to make the mistakes. Everybody. दोनों का भी देना है. You have to give both. Even if you're wrong, it's okay. Give the name. Line and histogram, continuous chart, normal distribution, plot, normal distribution plot. Okay. All right. What else? What else? और बताइए. Okay. Now write this down. Make these two graphs. The name of the first graph is called as, write this down, control chart. And the name of the second graph is called as histogram. Write this down, everybody. There were a couple of you who have given the right answer. Some of you are very close. It's not continuous chart, it is control chart. Okay. So you're very close, but not hitting the exact bullseye. Okay. You are very close. It's control chart and the second one is histogram. Everybody make a note of this. Now here is the bomb. Are you clear? Have you noted this down? Just give me yes in the chat box. Have you noted this? Just give me yes. Have you noted? First is control chart, second is histogram. Have you noted? Have you registered this? Now, the sentence which I'm about to say, this is a bomb for you. What is the bomb? Here is the bomb. The bomb is this. Let's say control chart is horizontal and histogram is vertical. Can you see this? Yes. Control chart is flowing horizontally and histogram is kind of, vertical. Okay. If I make the control chart, the horizontal control chart vertical, it becomes histogram. I repeat again. Listen to me very carefully. The first chart is, this is, let's say, this is the first point, this is second point, third point, fourth point, fifth point. So it is actually flowing horizontally, yes or no? It is flowing horizontally. And this one is, it's kind of a vertical structure. If I put my control chart, if I turn it around 90%, it becomes histogram. How many of you got it? Just type got it in the chat box. If I turn my control chart 90 degree, it becomes histogram. How many of you got this? How many of you got this? Just give me yes in the chat box. If I turn around my graph number 1, okay, for example, I'll draw this for you so that you will understand. If let's say if I draw this control chart like this, okay, the histogram is actually like this. Now, imagine if my variations are very high in the control chart, my graph will be a little flatter like this. How many of you got this? Just type yes in the chat box. If my variation in the control charts is very high, my histogram will be very much spreaded. Are you understanding what I'm talking about? I'm just relating control chart and histogram. And today's topic is related to that. How many of you got it? Just type yes in the chat box. So more the variation in the control chart, more will be the variation in the histogram. Lesser will be variation in the control chart, lesser will be the variation in the histogram. Exactly. So the same data, in other words, same data can be depicted in control chart and the same data can be depicted in histogram. And today's topic, which is control, the specification limit and the control limits, is basically got to do with these two charts, which is control chart and histogram. All right. How many of you got this? Just type yes in the chat box. The basic fundamental. I plotted two graphs. One is control chart, one is histogram. What I mentioned, if I turn around control chart 90 degree, that becomes the histogram. More the variation in the control chart, spread of the histogram will be higher. If less variation in the control chart, the spread of the histogram will be lower. Clear? This fundamental, if this is not clear, let me know in the chat box. Clear hai? Just give me yes. Everybody. Yes, no, yes, no. Yes? Fantastic. Exactly. So your y-axis data, I'm just doing it x-axis. That's it. in the histogram. Okay? Correct? So your y-axis data, I'm just putting in the x-axis. That's it. Okay. Now, let me just go ahead. Take a screenshot if required. I'll go deeper. First, I'll just open up one by one the layers of this concept. Okay. I want everybody to understand this. We will do Minitab exercise with this as well, so that everything will be clearer to you. Clear? Okay. Now, coming back to control chart, let me just speak about this chart number 1 right now. First, I'll speak about this. Then I will speak about this. Then I will speak about the control limits and specification limit. I will differentiate it. Then we will do a Minitab exercise on this. Okay. So let me talk about control chart. Now, control chart is a very important tool in statistical process control, which is called SPC. Okay. For your understanding, SPC stands for statistical process control. The father of control chart and SPC is Walter Shewhart. Make a note of this. Walter Shewhart. This is also called as Shewhart chart. Control charts are also called as Shewhart charts. Okay. Now, in the control chart, we have, let's say there's a process. Example. Let's say there is a weight of the product. You are measuring the weight of the product and you are plotting the weight of the product. Yeah, SPC meaning statistical process control. Statistical process control. This is a science which uses statistics to control the process variation. It's a science which uses statistics to basically, controls the process variation. It's called statistical process control. Now, in statistical process control, control chart is a very, very important factor. Control chart. Okay. And who is father? Walter Shewhart is father of control chart and statistical process control. Now, in this SPC or, control chart, according to Walter Shewhart, any process. Okay. Now, it can be the call time. Okay. Call time of, please displaying chat messages. It is disturbing. Chat messages disturbing कर रहे हैं क्या? एक minute. Let me just. But that is the only way of communication I have, actually, unfortunately. Anyway, let's see, because see, don't have a huge like our yellow belt session. No, we have people chatting all after every 5 minutes. Okay, ऐसे नहीं होगा, so कम होगा quantity. Okay, so here let's understand is statistical process control में any process. Now any process means, let's say, time of your calling. Okay, the call timing. If you want to plot the call timing on the graph, if you want the weight of the process, if you want the temperature of the process, any data from the process, if you want to plot any output data you want to plot, you can just plot it against the time. Okay, let's say this is the data you have plotted. Okay, I'm just randomly drawing this. There are three lines over here. The first line is at the center, which is the average line. Okay, just X bar is the average. The second one is called upper control limit. Now, this is very important. And just make a note of this. There is another line which is called upper control limit. And below that, there is another line which is called lower control limit. UCL, it's called control limit. Okay. And LCL stands for lower control limit, upper control limit and lower control. The formula for this is X bar is simple average. You take the data divided by number of data points. It's the average, right? The formula for UCL is X bar plus 3 standard deviation, and formula for LCL is X bar minus 3 standard deviation, 3 sigma. Just make a note of this. So according to Walter Sheward, let's try to understand this. According to Walter Sheward, any process which flows through these two lines called upper control limit and lower control limit, any process which flows through these two lines and not a single data point is going beyond that line, it's called as a stable process. Stable. What is stable? Stable meaning predictable. You can predict the behavior of the process. Any process which flows between +3 and -3 standard deviation is called as a stable process. And this chart is called as control chart. Are you clear with this? Just type yes in the chat box. Are you clear? Just give me yes, everybody. Everybody's clear about this? So let me give you some numbers. Okay. So if I'm collecting the weight of the product, imagine the weight of the product. Okay. The average weight of the product is 40 grams. I'm just giving you some random data. You have to tell me what is the upper control limit and the lower control limit. Average of the product, the average of that weight, average weight is 40 grams. And the standard deviation is, let's say, 2 grams. Okay. X bar is 40 and standard deviation is 2. Calculate UCL and LCL for me. So here, let me write down X bar is equal to X bar is equal to 40. Okay. And standard deviation sigma is equal to 2 grams. Can you calculate UCL and LCL for me? Yes. Mr. Raju, I will repeat this. First calculate this first. Everybody, I want everybody to calculate. Yeah. 34 and 46. Everybody got the same answer? So what is X bar? X bar is 40 plus 3 standard deviation, meaning 3 into 2, which is 6. So 40 plus 6 is equal to 46. Correct? So here 40 plus 3 into 2 is equal to 46. And x bar minus 3 sigma, the same thing. 40 minus 3 into 2, which is 6. So 40 minus 6 is equal to 34. So this particular process, if all the data points of the process, if they are flowing between 46 grams to 34 grams, then the process is called a stable process. So what I said earlier, any process, yes, Mr. Raju, any process which flows, just make a note of this, any process which flows between +3 and -3 standard deviation, okay, from the mean, it's called as a stable process. Stable meaning predictable. That means you can predict that process, the behavior of the process very easily. And this diagram, this graph is called as control chart. Clear, everybody? Just give me yes in the chat box. Everybody's clear about this? Super clear with this? Any doubt? Please let me know the doubt if you have. Clear? Very good. So this is called as control chart. Now question number 1, why it is only +3 and -3? After lot of permutation, combination and studies and experiments, Walter Shewalt realized that at +3 and -3 standard deviation, okay, you get some stability. All right. That's why he decides that +3 and -3 is the perfect equilibrium point where the stability can be tested. Okay, there is just a scientific reason behind it, which I will explain you in the advanced levels. Okay, maybe in the master black belt. The reason is at +3 and -3 standard deviation, standard deviation, alpha and beta errors are getting balanced. Just make a note of this. I will explain you sometime later. At +3 and -3 standard deviation, alpha and beta. So alpha is written like this, alpha, okay, and beta errors are balanced at +3 and -3 standard deviation. That is the reason why Walter Shewart decided to go for +3 and -3 standard deviation to check the stability. Just make a note of this. Clear, everybody? Yeah, alpha and beta are the errors which we will cover in the advanced hypothesis testing. Okay, it's a big topic to understand. Just make a note of this. Okay, I'm just giving you the reason behind it. I will explain the reason because that explanation requires maybe 45-50 minutes. Okay, just write this down. And alpha and beta error, at +3 and -3 standard deviation, alpha and beta error gets balanced out, and you will study a little bit of alpha and beta error in hypothesis testing. Okay, in hypothesis testing, I'm just writing this down. You can find out alpha and beta error in hypothesis testing. So in the green belt and black belt hypothesis testing also, we touched upon alpha and beta error as well. Okay. So control chart is very clear. So any process which flows through + and -3 standard deviation is found to be a stable process. Now, what about the control charts? If you see the formula, okay, the process variation. Now listen to me very carefully. This is very important sentence. The process variation defines the control chart itself. That means the control limits are decided by the process itself. Make a note of this. The control limits, which is upper control limit UCL and lower control limit LCL, are defined by the process itself. Are you understanding? Yes, because the sigma is nothing but a variation of the process. The X bar is nothing but the average of the process. Correct? So both are decided by the process, the average as well as the variation. There is no other, there is no customer or there is no company deciding this. Process itself is deciding upper and lower control limits. Are you clear with this point? Just type yes in the chat box. Are you clear with this point? Just type yes in the chat box. Clear hai? Everybody, I want everybody in the room to type yes or no. If not clear, type no, not clear. If clear, just type clear. Exactly. Upper control and lower control are decided by the customer. Clear? Fantabulous. Very good. Fantastic. Super. किसी को नहीं समझा है तो प्लीज टाइप नो. आई विल एक्सप्लेन इट अगेन. वेरी गुड. Anshuman ji, I think you have just entered right now, right? So we are talking about the control chart, which is nothing but, it is just like a run chart. Are you aware of run chart? Just a simple run chart like this. If I plot the process running, okay, if I plot, every day's production, okay, yes, correct. Or, the everyday's, the share market price, the share price, correct? Very good. Now, if I add the 3 lines to the run chart, the first line is called X bar, which is the average. Okay, X bar, which is the average line. Second line on the top side, if I add the upper control limit, the formula is X bar plus 3 sigma. And the third line is lower control limit, X bar minus 3 sigma. Okay, which is on the both sides of the X bar. Right? So first the process I plot, I check the X bar, which is the average. I check the standard deviation of the process. Then I calculate upper control limit. I calculate lower control limit. There's 3 lines I calculate. So whatever data I have, I calculate these 3 lines. That means these control limits are decided by my process itself. Nobody has told me that you have to fix your control limits here. Are you clear with this point? Just type yes in the chat box. So the control limits are decided by the process variation itself. Clear, everybody? Anshumanji, Manojji, and Vishalji, are you clear? Yes? So I've just plotted the process. X bar is plotted, the average, simple average. And on the average, UCL and LCL is calculated. Simple. So whatever data I have, that data itself is deciding my control limits. Okay. So this is about stability. So whenever any process, the statement, so if I've joined just now, the statement is any process which flows between +3 and -3 standard deviation is a stable process. Any process which flows from between +3 and -3 standard deviation from the mean, it's called a stable process. This is called stability check. So control chart is nothing but a stability check. Okay, stability check. So stability. That means the process is stable. Stable meaning the predictable. Okay. 3 SD is standard. Yes, it's standardized. It's absolutely standardized. 3 standard deviation is standardized. Okay. By Walter Sheward, who is father of control chart. Okay. Let's move forward. Now, let's go ahead. Now, what do you mean by stable process? Stable meaning predictable. We can predict the behavior of the process for going forward as well. Okay. Now, on the other side, let me talk about specification limit. Okay. Specification limit. Now, how many of you in your company use specification limit? Give me some example in the chat box. Specification limit. Everybody, give me some examples in the chat box. Everybody, write your specification in the chat box. If you are using Assay 9505, fantastic. Superb. Here is very nice. So, yeah, tolerance, exactly. Temperature 20 and 40. Fantastic. So there is something called lower specification limit. There is something called target, and there is something called upper specification limit. This is the target which you want to hit, and there is a process in between. Okay. So, yeah, frequency 50 plus minus 2%. That means 48 to 52. So lower specification is 48, upper is 52. Correct? Assay 95, 105, meaning target is 100, 95 is lower specification, and 105 is upper specification. Very good. What else? Temperature 20 and 40. So 20 is lower specification and upper is 40 degrees centigrade. Maybe target will be 30 degrees centigrade. So these are called specification limits. SLA 98 and 99.5. So 98 is the lower specification, 99.5. Now these are called specification limit. Who decides the specification limit? Your customer decides. Your customer decides the specification limit, and they will, whatever product which is there within the specification limit, customer will accept it. Whatever product which is not within the specification, customer will not accept it. It will be called as a defect or rejection. Correct? So if any product goes, let's say you have 50 plus minus 2, right? So let's say 50 plus minus 2 meaning 48 and 52, right? 48 and 52. If you have a data point at 53, that will be rejected. And if you have a data point at 47, that also will be rejected. Clear? It is called out of specification. Absolutely right. So the specification limits are decided on the basis of customer demand, customer requirement. So customer will tell you, within this and this, I will accept your product. Otherwise, I will reject. Are you clear? So specification limits are decided by the customer, and control limits are decided by the process itself. Are you clear the differentiation? Just give me yes in the chat box. समझ में आया ये difference? Just give me yes. Everybody's clear? Lower specification and upper specification, and not control. Clear, everybody? Just give me yes in the chat. This is decided by the customer. Now, customer will give you the specification. If your process is within this, customer will accept it. If your process is not, okay, let's say your process is like this. If I draw a process like this, so whatever goes beyond, okay, this all will be rejected. This is called as defect. Exactly. So this is, now when I say customer, it can be your regulator as well. When I say standard, understand this. When it comes to the IS standard, EN standard, etc., the specification limit can be decided by the standards as well, by the regulators as well. Sometimes the specification limits are decided by the government as well. In that case, let's say pollutions. Okay, how many ppm you should release in the air? If the pollution control board has given you specification limit, so then pollution control board become the regulator and your customer. So whatever gases you are releasing in the atmosphere, it should fall between that specification limit. Are you clear with this? So specification limits are decided by someone else, the customer, the regulator, etc. And the control limits are decided by the process. Clear? Just give me yes. Clear है? Now just draw these two lines and check the differentiations. Okay? Music decibels, exactly. The same thing, music decibels. Now just draw control limits and specification limits. A lot of people get confused between it. That's what I chose to take a session on this, because there are a lot of confusion. A lot of people ask me the questions in the mentors WhatsApp number as well, so that we decide the topic about it. Now control limits, you just write down. Control limits are basically decided by process. Decided by process itself. Whereas the specification limits are decided by the customer. Write this down. Okay. The second, we use control chart. Okay. Here we use histogram to show specification limit. Correct? I show you histogram like this, right? And here we use the control chart, correct? Like this. So the third one, this is very, very important. Now, in the control chart, within that band of, upper control and lower control limit, okay, there is a variation within the limits, within the upper and lower control limit as well, right? That is called common cause variation. Understand this. Within that limit, within that upper and lower control limit, whatever is the variation, that variation is called common cause variation. And any variation which is going beyond the control limit, it's called as special cause variation. I'll give you example. Your office arrival time. In your office arrival, there is always small variation of 5 to 10 minutes. Yes or no? Everybody just give me yes or no in the chat box. Every day you have 5 to 10 minutes variation in office arrival. Yes or no? Just give me yes or no. Correct? That variation is called common cause variation. That is because of your normal traffic, your waking up variation, your what you can say, your because of the lift. Okay, so these are all common causes. But one fine day, you had you had your vehicle, what you can say, your tire flat. Okay, when on that day, what will happen is you will come maybe 1 hour late. You will come 1 hour late, yes? And that day, that data point will be beyond control limit, and that is called as special cause variation. So within the control limit, the variation is called common cause. Beyond control limit, it's called special cause variation. So let me write down beyond control limit. Beyond control limit. Beyond control limit. It is called as special cause variation. And beyond, now coming back to the specification limit. Beyond specification limit, if any data point goes, what does it call as? Write this down in the chat box. Beyond specification limit, if any data point goes, then what does it call as? Type in the chat box. Exactly. It is called as defect or rejection. Clear? defect or rejection. Or out of specification, exactly, which will be rejected. Okay, clear hai? Now, the fourth point will be, with the control chart, we check stability. Stability, okay? क्या लिखा मैंने? एक सेकेंड ना. Stabi, हाँ, okay, yes, now it is right. So stability, and in the specification limit, we check process capability. Write this down. Process capability. Okay. So process capability is decided with the help of specification limit. So what we do, we take the process, we put the specification limit, and whether the process is capable or not, that capability checked with the help of specification limit, and the process is stable or not, that stability checked by the control limits. Just make a note of this. Take a screenshot of this. Just take a screenshot of this, everybody. Clear hai everybody till now with me? Just give me yes in the chat box. Super. So I'm just giving you, yes, I'm just giving you one Minitab file. एक बार Minitab में हम लोग control chart, the control chart as well as the specification, दोनों करके देखते हैं, ठीक है? So I'm just giving you a file name as process capability normal. Just open that file. You can just click on that file and open that file. Let me also open that file. Once you open that file, let me know in the chat box that file opened. In the chat, you can find out. Or you can open any data file, or you can create the data. You just open any blank sheet and you can create the data. Opened, everybody? I'm just waiting for you. Just give me yes. Yeah, thank you very much. हाँ, yes, yes. चॉकलेट खाएंगे अभी. Now, the people who do not have the sorry, have the file, open any Minitab blank worksheet and create the data. Okay. How do you create the data? Just listen to me very carefully. Go to calc, random data, normal. Okay. If you don't have the file right now, open any blank Minitab worksheet and just follow this process just to generate the data. That's it. Go to calc, random data, normal. Everybody just follow this if you don't have this file in front of you. Okay. Calc, random data, normal. This window will appear. So let's generate here. Let's generate 30 data points. So I'll type 30 here and I will store in the column C3, because C1 and C2 are already occupied, column C1 and C2. Okay. In the mean, I will just type, let's say 40. Okay, that's it. I will not do anything after that. Okay. So here I've taken 30, C3 column, and mean I've taken 40. You can take 30, 40, 50, anything. Okay, and just say okay. And so I have generated some data here. You can see here. So I will type data. So I can either use this data or I can use this data. Clear, everybody? If you don't have this file, you can generate the data like this. Yeah, I'll repeat again. Go to calc, random data, normal. Just follow this path. Write this down. Calc, which is calculator. In the calc, from the bottom third position, which is random data, and normal, because we are talking about a normal distribution. Okay. Calc, random data, normal. Just click on that. In the number of rows, that means how many rows you want to generate the numbers. I have just written 30. You can give 50, 100, 1000, whatever you want. Store in the column C3. Okay, so because column number 1, C1 and C2 already have the data. So I've chosen C3. And here mean and standard deviation you have to give, right? So I've just given mean as 40. You can give 20, you can give 10, you can give whatever. Okay. And just click on OK. You will find out this data. Clear? All right. Now, so first we will create the control chart. Okay. How do we create the control chart? So I will create a control chart of this data itself. Okay. नया data को control chart बनाएंगे. Go to stat, control chart, variable chart for individual. Everybody follow this path. Stat, control chart, variable charts for individual. Stat, control chart, variable charts for individual. If you follow this, just click on this individual. Stat, control chart, variable chart for individual. Just click on that. Now in the variable, either you can select chocolate weight or you can select the data. So I'm selecting the data. Okay. So this is the data point I want to make a chart of, right? And just say okay. And the data has basically calculated the control chart. Everybody got this? Just give me yes in the chat box quickly. You have got this graph. This is called control chart. The first chart, what we have. Yeah, Ajay ji, have you have the Minitab with you, right? Have you downloaded Minitab? Okay. So where have you stuck? Let me know. Have you generated the data? Okay. So let me go again. Let's generate the data. Okay. Open any Minitab file. Have you opened the Minitab file? Yes. Very good. So let's say there is a blank Minitab file in front of you. Go to calc, random data, normal. But here, yeah, see, because there will be some variation in the process, right? Okay, done. So click on that. Now you generate 30. So here you put 30 number of rows. So how many number of rows you want to generate? In the column C3, because if you don't have anything, just you can select C1 column. Okay. And I have selected mean 40. You can select 20, 30, 20, whatever you wish. And click on OK. Just click on OK. It will generate some data points. Okay, done with me till now. Okay, आगे data points. Just give me yes. Data not generated, is it? With the same formula, it is not getting generated. Which Minitab version are you using right now? From our Minitab only, right? Or you have some other version of Minitab? Better to. I think other. Which version are you using? You have some. You must have some other office version. ओके, एक काम करो अजय जी, एक काम करो, ये जो है ना अपना वाला जो वर्जन ना विनिट एफ 17 वाला वर्जन, जस्ट गेट इट डाउनलोडेड ओवर देयर, ओके, या सो दैट विल बी बेटर फॉर यू टू प्रैक्टिस. ठीक है, अभी जस्ट लेट्स ऑब्जर्व. सो व्हाट वी हैव डन, दिस इज द डेटा. नाउ व्हाट वी आर डूइंग इज वी आर मेकिंग अ control chart. So we are going to stat control chart, variable chart for individual. Okay. And we are selecting the data and we are clicking on OK, and we are getting the control chart like this. Yes. Now here you can see the X bar, which is actual X bar, is because it's randomly generated data. Okay. It's randomly generated data. So the X bar is this UCL. If you remember, the formula is X bar plus 3 times standard deviation, and LCL, which is X bar minus 3 times standard deviation. We have the control limits. Okay. Now, any variation within the two limits, it's called. So this is the band. If I am talking about this band completely, okay, this complete band, it's called as common cause variation. As of now, the process is stable because not a single data point is going beyond control limit. Imagine there would be 1 or 2 data points which were going beyond control limits. Okay, like this. Then this is called as special cause variation. Clear? Just like your car broke down and you came 1 hour late. That is a special cause variation. Are you clear? Common cause variation within the control limits. Now, here is a secret. Okay. Special cause variation is very easy to identify and eliminate. Make a note of this. Very, very important statement. Special cause variation is very easy to identify and very easy to eliminate. But common cause variation is very difficult to identify the reasons and very difficult to eliminate. This part within the control limits, it's very difficult to eliminate or reduce. Special cause variation, there are obvious reasons and we can immediately take some actions to eliminate it. But common cause, see, we use 6 sigma methodologies, not for special cause variation, but for the common cause variation to reduce. How many of you have got the bulb on moment? Just type BO in the chat box. 6 sigma is not used for this. 6 sigma is used to reduce this variation even further. Even compressing the common cause variation. You cannot eliminate common cause variation, but you can compress it further toward the center. Are you clear with this? Just type yes in the chat box. Are you clear with this? Just type yes in the chat box. Special cause variation, you just need logical thinking to identify the reason. But for common cause variation, very difficult to identify the reason. And that is why we go for fishbone analysis. You know, man, machine, method, mother nature, material, etc. And then we identify causes, root causes, hypothesis testing, regression, etc. Yes, let me repeat this. Special cause variation, write this down. Special cause variation is very easy to identify and eliminate. And common cause variation is very difficult to identify, the reason, the common causes the causes, basically. It's very difficult to identify the causes and eliminate the causes. And that's where Six Sigma comes into picture. Six Sigma is not used for the special cause variation, but it is used for the common cause variation. Okay. So this is called as control chart. Clear hai control chart? Are you clear? First part is clear with the mini tab. Just give me yes in the chat box. Now let me go to the second part, which is the specification limit. So control limit is clear. Let me go to the specification limit, which is the second part. Exactly. Yes, very good. So which requires deeper analysis. And that's where our Six Sigma tools come into picture. Okay. So, your logical thinking, your, what you can say, common senses will not be applicable for common cause variation elimination. Okay. Yes, common sense will not be. So you have to go deeper into, cause and effect, root cause analysis, hypothesis testing, etc. Okay, let's move to the second part, which is nothing but our. Now let's calculate the, the process capability. Okay, imagine for this, the upper specification limit is, let's say, 45 and the lower specification limit is 35. I'm just giving you some specification limit, let's say decided by the customer. Okay. So let's find out what is my sigma level in this. Okay. So how do we find out that? We go to stat, quality tools, capability analysis, normal. Everybody follow this path. Stat, quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. Yeah, just make a note of this. Click on that. Now here in the single column, select the data. Double click on data, whatever data you have selected. Subgroup size, let's consider as 1. Okay. Lower specification limit as 35. Upper specification limit as 45. And everybody with me? Single column may put data. Subgroup size is 1. Lower specification 35, upper specification 45. Go to option and just select benchmark Z. Select benchmark Z here. In the option, just select benchmark Z and click on OK. And click on OK. And here we go. So right now, our Z bench is 4.43. That means my current process capability is, my current process is 4.43 sigma process. This is my Z bench value. I mean, if you got this, just type yes in the chat box. Your numbers would be different because your data is different. So you can decide the specification limit and the data. I repeat the whole entire exercise once again. This is my data. I want to find out the specification limit for this. Want to find out the capability. Okay. Now control limit we have seen. I want to check the specification limit and the process capability. So what I'll do is my specification limit are 35 and 45. Lower is 35, upper is 45. Okay. I go to stat, quality tools, capability analysis, normal. Just give me a signal if you are with me. Just give me yes in the chat box. Stat, quality tools, capability analysis, normal. Everybody. Click on normal. select in the single column, select the column which you want, to analyze. So I've selected the data column here. Subgroup size is 1. What is subgroup size? Subgroup size is nothing but, are you taking only one sample, one data at a time, or you taking a group of sample? Subgroup meaning a group of sample. Okay, here we are taking only one data at a time. That's what I've taken only one. Okay. Now here lower specification 35, upper specification 45. Are you with me? Give me yes, no. So single column data, subgroup size is 1. Lower specification is 35, upper specification is 45. Okay. Then I go to option. And in the option, instead of CP and PP capability stat here, I'm selecting benchmark Z, sigma level, benchmark Z, and click on OK. Subgroup 1, because in this data set, I'm taking individual data, one data point. That's what I've taken, subgroup 1. If I would be taking 5 group samples, 5, then I would have taken subgroup as 5. If I'm taking 10 sample, let's say chocolate weight. If I'm taking 10 chocolates at a time as a subgroup, as a group of samples, so my subgroup size will be 10. Okay. So here I've just taken only one sample at a time. So I have taken subgroup as 1. Okay. Now, once you have selected, just click on OK. Now you will get this diagram. Now, everybody got it? The people who said repeat. Okay, Sachin ji, Radha Krishna ji, and Manoj ji. Are you with me till now? Capability index mein, if you go to option, no, in the capability, just select benchmark Z here. Eye chart is individual contributor. Exactly. Very good. Eye chart is individual. I means individual, right? Yes. Here, capability index. See, if I go back to quality tools, capability analysis, normal. Okay. If you select normal, then single column mein data, subgroup size is 1, specification limit you put. Okay. So let's say how to select the data. Let's say if I remove the data from here, if I click here, on the left hand side, you will find all the columns displayed. If I click here on the single column, all the left hand side, the columns will be displayed where the data will be there. You have generated the data, right? If you have generated the data, it will be displayed over there. Just double click on that, it will get selected. Let's say, for example, if I double click on data, it will get selected. Clear, Sachin ji? Just give me yes in the chat box. Very good. Okay. Everybody got this? So when your Z benchmark Z is this 4.43, that means it is called as 4.43 sigma process. Okay. So this is called as process capability analysis. Whenever this Z bench becomes 6, that becomes your 6 sigma process. If this becomes 6, that becomes the 6 sigma process. Clear? So this Z bench is a very, very important character. Are you clear? So specification limit decided by the customer to check the process capability, and control limits are decided by the process itself. Okay, on the basis of the variation. Can we change the control chart name and when we take subgroup 5? No, when we take the subgroups, then it will go for X bar R and X bar S chart. Right? When we have individual chart, okay, So there are two types of charts, right? One is subgroup chart and one is individual chart. So I for individual. So when we take individual data points, we have to select I chart, individual chart. If we are taking subgroups, okay, then you have to go for X bar R or X bar S. So these are two charts available for us, correct? Super. Very good. Chalo. So clear hai everybody with me? Yes? What is overall and within? So overall and within is nothing but a short-term and long-term process capability. Okay. Short-term and long-term process capability. So this is a short-term process capability. And this is a long-term process capability. So basically this is descriptive statistics. And this is inferential statistics. Which will cover, I will cover this descriptive and inferential in some other. So, and see what happens is if we have the group of samples, imagine, uh, let's say we have 30 data points, but these 30 data points, I have selected five groups. Okay. So 5, 5, 5, 5, 5, and 5. So I have taken five chocolates each 6 times. Now, so this is called a subgroup. Okay. Now, if I take these 5, this also will have some variation. Okay. This also will have some variation. Correct. Some will have small variation. Some will have more variation, etc. Right. So this is called within variation. This is called within variation. Okay. If I take the variation of these subgroups, small 5, 5, 5, 5 groups, there will be within that subgroup also there will be some variation, right? That is called within variation. Now, instead of this, if I mix all the 30 data points, and that becomes the overall variation. If I mix all the data points together and I calculate the variation, that is called overall. So within meaning within the subgroups variation, and overall meaning if I mix all the data set together, whatever variation is there, that is called the overall subgroup. Okay. What does CPM means? Kahan pe CPM? Acha, CPM. Okay, this one. See, CPM is nothing but CPM क्या है मालूम है? Just a second. So this is called CPM when we give some target to this, it is nothing to do with critical path method. Okay. No, this is not. This is process capability wala CPM hai. This is not critical to path method. Now understand this. Instead of this, let's say, if I give a target. Now, you remember we put LSL and we put USL. You remember USL and LSL we put? LSL was 35 and USL was 45. Remember everybody? Just give me a in chat box. Correct? Everybody remember this? Did we put target? Did we put target? We did not put target. Okay, let's say if we put target here, we will get some CPM number. Okay, let's put it over there. So here you will find some CPM number. एक बार करके देखते हैं. Let's go back to the data. Go back to the data. Okay. And let me see. Target डालते हैं. हाँ, इधर यहाँ पे. Target in the option column itself. There is a target. Let's put target as 40. Everybody. Yeah, CPK is process capability index. Okay. It's process capability. CPK and sigma value, it's the same thing. I'll explain you. Just put target. Everybody, just go back to option and in the target, just put 40 and click on OK. You will find a CPM value here now. Can you see CPM? 1.36. So that means what does it mean? So this is the process, correct? How well are you So this is, let's say, this is the mean of the process and this is the target of the process. So how well are you performing between the target and the mean of the process? That is what the CPM is all about. Clear? So if you put a target into target value, the CPM value will emerge. Just give me yes in the chat box. So I will cover this CPK, CPCPK, sigma value in some other topic, because it will require a lot of time to explain. But clear as CPM is for the target value. If you put a target value, you will get a CPM value as well. And CPM is not critical path method. वो project management वाला CPM नहीं है. This is a different CPM. Okay. Any other question? If you have, let me know in the chat box, or you can just raise your hand. And we'll go. You can unmute and ask the question as well. Both options are absolutely okay. Haji. See, CP-CPK, meanwhile, there is a deeper connection between the CPK value and sigma level. Okay. Just make a note of this, everybody. What is the connection of CPK and sigma value? If your CPK is 1, if your sigma is 1, which is 1 sigma process, your CPK is 0.33. When your sigma is 2, that means you have a 2 sigma process, your CPK value is 0.66. When you have a 3 sigma process, your CPK value is 1. When you have a 4 sigma process, your CPK value is 1.33. When you have 5 sigma process, your CPK value is 1.66. When you have 6 sigma process, your CPK value is 2. And there is an assumption, which is the mean of the process is equal to the target of the process. If this happens, then this will be applicable. Just make a note of this. इसको मैं कभी और explain करूंगा. Just make a note of this, is very important. So when you have 6 sigma process, your CPK value is 2. Right now our CPK value is 1.48. Okay, and our sigma Z bench value is 4.4. Right? So you can see here 1.33. If it would have been 1.33, it would be 4. Z bench would be 4. Correct? If this would be 1.48, it is around 4.43. So you can just make a note of this. Everybody? Super clear? Just note it down or take a screenshot of this. Kashi, you are absolutely right. If the process is shifting on this side, your CPK values, CPM values will be basically changing. Clear? Super. Haji Talib ji, you can unmute yourself and ask the question, please.
Good evening, sir.
Good evening. Good evening. After a long time, huh?
After a long time, sir, I will attend the class.
Good.
Because previously I joined the class at that time I am in a general shift. But right now I will change the company. So they appointed a shift wise. Okay. But I regularly see your recorded classes.
Good. Yeah. Anyway, you can check the recorded classes anytime. Yes.
Yeah. But today I am asked one question. मैं अभी आपके बहुत सारे क्लासेस देखे जिसमें आपने एक चीज एक्सप्लेन की सिग्मा को मैनुअली आपने एक्सप्लेन किया बहुत ही मतलब एक औसम लेवल. मतलब वो एक कॉन्फिडेंट देता है कि हाँ हम कुछ भी करा सकते हैं किसी से भी. ठीक है, ये तो है ही हमारे पास सॉफ्टवेयर के थ्रू जा सकते हैं, लेकिन मैनुअली जब मिलता है तो कॉन्सेप्ट क्लियर होते हैं क्या बोल रहा है चीज.
करेक्ट परफेक्ट.
तो मेरा एक आपसे रिक्वेस्ट है सर कि एमएसए जैसे एमएसए निकालते हैं तो एमएसए में हम 2 डाटा होते हैं हमारे वेरिएबल एंड एट्रीब्यूट. तो वेरिएबल के लिए हम 2 तरीके से निकालते हैं, एनोवा एंड एक्स बार एंड आर बार.
करेक्ट.
तो एनोवा से कैसे निकालते हैं मैनुअली सर चाहिए. और एक्स बार आर बार से कैसे निकालते हैं.
करेक्ट.
ठीक है. और एक एट्रीब्यूट से जो होता है उससे हम कापा वैल्यू निकालते हैं, तो वो मैनुअली कैसे कापा वैल्यू निकालते हैं, एक तो ये सर आपसे चाहिए.
ओके.
आपके पास अगर वीडियो है तो सर वो ठीक है, क्योंकि सारी वीडियो भी नहीं देख पाया मैं।
हाँ
तो
हाँ
वो एक बार लिंक शेयर कर दीजिए सर मुझे, या तो वो है या
हाँ,
फिर क्लास ऐसा कोई क्लास में ही ले लीजिए तो वो और बेटर गुड हो जाएगा सर।
गॉट इट
एक तो
गॉट इट।
ये, दूसरी चीज ये कि जो हम एक्स बार आर बार में निकालते हैं, क्योंकि मैंने
हाँ
ये रीड आउट किया है,
हाँ
तो उसमें हम जी आर आर वैल्यू निकालते हैं। और जी
हाँ
आर आर वैल्यू अगर हमारी अबव द 30% आती है, तो
हाँ,
हमारा इसका मतलब क्या है, वेरिएशन ज्यादा है, हमें इसको रिड्यूस करना है।
करेक्ट
और
करेक्ट करेक्ट
वेरिएशन दो टाइप्स के होते हैं, एक होता है अप्रेजर वेरिएशन, एक होता है इंस्ट्रूमेंट।
करेक्ट।
तो अब हमें एक्शन किसके ऊपर लेना है? जी आर आर वैल्यू तो हो गई,
हाँ,
क्योंकि जी आर आर वैल्यू होती है अंडर रूट ऑफ अप्रेजर वेरिएशन का स्क्वायर प्लस
करेक्ट
इंस्ट्रूमेंट वेरिएशन का स्क्वायर, मतलब दोनों का स्क्वायर का अंडर रूट होता है वो,
करेक्ट
अगर
करेक्ट
फार्मूला की बात करें तो।
करेक्ट।
तो अब मेरा जी आर आर वैल्यू अबव द 30% आया,
हाँ
अब मुझे एक्शन किस पे लेना, अप्रेजर के ऊपर लेना
हाँ,
है या फिर मुझे इंस्ट्रूमेंट के ऊपर लेना है?
yes,
वो
in
कैसे
that
डिफाइन करूं?
in that variation also ना we get to know lot of signals, okay? वहां पे
हम्म
हमें एवी का भी मिल जाता है और ईवी का भी मिल जाता है। इफ
हम्म
ईवी का वेरिएशन ज्यादा है, ईवी स्क्वायर इज मोर, that means
हम्म
equipment variation is more, that means we have to focus on the equipments, okay? If AV square is more, that means appraisal variance is more, that means we have to basically give the training to the operators, etc. Okay.
अकॉर्डिंग अकॉर्डिंग टू यू सर, कि जो
हाँ
हम ईवी, वी व्हेन वी कैलकुलेट द ईवी, ईवी
हाँ,
आल्सो इटसेल्फ इंडिविजुअल कैलकुलेट एंड
करेक्ट
एवी आल्सो इंडिविजुअल कैलकुलेट। तो
करेक्ट
वैल्यू ऑफ ईवी इज मोर या वैल्यू ऑफ एवी इज मोर,
करेक्ट,
coming more value, the that will take the action of more value.
exactly, more the value, that means more the variation, very simple,
ओके
because we are
ओके
calculating
ओके।
the value now. We are
हम्म
EV मतलब क्या है? Equipment variation ना, equipment
हम्म
variance, variance means
ओके
the
ओके।
variation. So equipment variance ज्यादा है तो we have to focus on equipment variance, and
ओके ओके।
appraisal variance more है तो we have to focus on appraisal variance.
But I can't see anywhere the band like as here is band available,
हाँ
10 0 से 10% desire,
हाँ
10 से
हाँ,
20% acceptable,
करेक्ट,
20 to 30% may be acceptable,
हाँ
above the
हाँ,
30%
we have to
reject.
reject, we have to reject, yes, we have to
But
reject the skill.
there is no any band I found, so many classes in your
हाँ हाँ
curriculum. But
हाँ
I also search in YouTube also.
हाँ
There is
हाँ
no band available. कि
हाँ, तो
maybe
सो
that
एवी,
could.
एवी और ईवी का स्पेशल बैंड नहीं है ऐसा, ओके?
हाँ
बट
हाँ हाँ
एज एज यूर क्वेश्चन सजेस्ट, उसमें से कौन सा हमें निकालना है कि कौन सा ज्यादा है, ओके? सो वी
यस
कैन
यस।
इजीली फाइंड आउट फ्रॉम द वैरिएंस पॉइंट ऑफ व्यू। बट एज फार एज
ओके।
बैंड इज कंसर्न, जो एआईएजी गाइडलाइंस के हिसाब से, सो दे हैव गिवन द
हाँ
ओवरऑल का जो वेरिएशन है ना, दैट हैज टू बी लेस देन 30% टू एक्सेप्ट द योर स्केल,
ओके ओके, मींस इसका बैंड नहीं है हमारे
या
पे,
इसका,
हाई
या
नहीं।
उसका सेपरेट बैंड नहीं है। यस यस, यू आर राइट।
ओके ओके, करेक्ट करेक्ट करेक्ट। ओके सर, तो ये सर वीडियो सर, और पहली चीज तो इसकी वीडियो सर
हाँ, मैं
एमएसए के,
करेक्ट
फिर
करेक्ट करेक्ट।
एसपीसी
आई
एंड
थिंक
एंड एसपीसी।
आई थिंक वन ऑफ आवर मेंटर हैज सजेस्टेड दैट एनोवा वाला एक वीडियो आपको दिया था, वो आपने
हाँ हाँ
देखा
हाँ,
क्या?
वो दिया, मैंने देखा
हाँ,
उसको।
एक बार देख
अब
लीजिए, वो
एक
अच्छा
बार जब
है।
सर, अब जब आप क्लास में पढ़ाएंगे तो वो
हाँ,
फॉर बेटर होगा सर।
चलेगा चलेगा, एक्चुअली वो उसका ही रिकॉर्डिंग है, वो क्लास में ही गया है, लेकिन आई विल टेक दैट रिकॉर्डिंग वन सेकंड, ओके?
ओके ओके ओके
या
ओके।
या,
एंड एसपीसी मतलब कंट्रोल प्लान, देयर इज सो
हाँ
मेनी कंट्रोल प्लान, कंट्रोल प्लान्स आल्सो डिपेंड ऑन डाटा। डाटा मींस टू टाइप्स ऑफ डाटा, वेरिएबल एंड एट्रीब्यूट। तो
करेक्ट,
वेरिएबल के लिए एक्स बार आर बार एंड
हाँ
एम आर चार्ट लाइक दिस कंडीशन।
करेक्ट।
एंड एट्रीब्यूट के हाउ मेनी कंट्रोल चार्ट इज देयर, तो हाउ टू
सो
कैलकुलेट इट?
सो पी चार्ट, सी चार्ट, यू चार्ट,
P chart,
एनपी
C
चार्ट,
chart, U chart, NP chart.
फोर
But
चार्ट
how
गुड
to
है।
calculate? How to calculate manually, sir? Not through the software.
तो उसके भी फॉर्मूलाज है ना,
Yeah.
मैन्युअली
We
भी
want to formulas.
हाँ, उसके फॉर्मूलाज है। आपको फॉर्मूला चाहिए तो मैं आपको दिखा देता हूँ, फॉर्मूला मैं आपको उसमें डाल भी देता हूँ, जस्ट फॉर
नहीं
योर
सर, वो कैलकुलेशन
इंफॉर्मेशन।
कहीं ऐसा वीडियो है जो कैलकुलेट जिस तरीके से सर सिग्मा समझा है ना,
हाँ
वो चीज मैं चाहता हूँ सर।
अच्छा अच्छा, ओके। सी वी कैन सी, वी कैन
क्योंकि
डू।
वो मुझे बहुत ही कॉन्फिडेंस दिया कि मतलब किसी को बताने में, किसी तब लगता है कि
सी
आपने कुछ किया है।
what happens now, what happens everywhere you can calculate manually, okay?
जी
But
जी जी।
see, for understanding purpose, great, but we are not going to be using it in the regular basis,
No
okay?
no 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 no
हाँ,
no sir, we are going regularly, we are going to the
करेक्ट,
software, but
यस यस यस,
understanding level is
हाँ जी
more.
हाँ जी। मैं इसमें भी ना आपको एक ये डाल देता हूँ। एवरीबॉडी यू कैन जस्ट ऑब्जर्व दिस, आई एम जस्ट पुटिंग वन फाइल, मे बी आई जस्ट पुट दिस फाइल इन our master class archive as well, okay? Satish ji, I've just put it master class archive for the new members. All the recordings are available in the master class archive. Once the session is over, the recordings will be basically, I believe I have started the recording, right? I believe that is, yes, recording is on.
Yes,
Hang on.
recording.
Okay. Yes. So here we go. So this is, just observe this. Okay. There is one file for everybody. Okay. And today's session also is related to this. Okay. So how do you calculate control chart with, there are various control charts are there. See, today's topic was not control chart, but control limits, right? So I limited my explanation to the limits only, control limits. But as far as the control chart is there, you can just download this file, which I've just put it in the chat box. Plus, उसमें calculation का formula भी दिया हुआ है. Okay, which control chart, which formula is, control chart को, ये control, इसको लिमिट्स को कैलकुलेट करने का फॉर्मूला जो है ना, एवरी कंट्रोल चार्ट का फॉर्मूला दिया हुआ है इसमें. ठीक है, यू कैन जस्ट रेफर दैट.
Okay, sir. Okay. Yeah. And last one question, sir. One line question is there. PPK and CPK. That last time I gave the interview in other company. They asked me PPK and CPK. I simple told you कि PPK long term and CPK is short term. But I also confused कि what is short term and what is long term.
हाँ, see, short term and long term मतलब क्या है? Long term का, see, definition of long term is very simple. Long term is, the definition is, so a lot of people get confused. So they ask the question that, sir, is 6 month long term or 1 year long term? The question itself is wrong. Long term, the definition is whatever time frame encompasses all the possible, variation of the process. I repeat again, a very, very, very important question, very, very important answer. If you give this answer, okay, you cannot be rejected in the interview. Okay, give this answer. Any time limit which encompasses all the possible variabilities. For example, let me give you an example of a sales, cold drink sales process. Okay, in the cold drink, selling process, in the summer vacation, the sale goes up. In the winter, the sale goes down because of, consumption is very less. So there is a cyclic pattern which stays there for complete year, right? So for them, they have to consider 1 year as a long-term variation. So for them, 1 year encompasses or encloses all the variation in the process. So for them, 1 year is a long-term variability. And then whatever they are taking, 1 week data, one shift data, or 1 day's data, that is a short-term process capability. So CPK is for the short term, and for 1 year, that will be a long term. Now, long term is different for different process, different industry. Okay, so always remember this definition. Any time frame which encompasses all the extreme values, all the variabilities, that is called the long term, and that's where the PPK comes into picture. Okay.
In automobile sector, can we take the example, sir?
Now, now it depends on what component we are talking about. Now, some automotive components are, they have the life
just we calculate the OD of any parts, and we calculate the CPK value and PPK value.
Correct. So see, generally what they do is, in the automotive sector, they decide, because of the design team, etc., the R&D design team, they decide the lifespan of that, entire the process or entire component. Okay, so they collect the data of that much of time. Okay, and that becomes their PPK value, and whatever the short-term sampling they are taking, that becomes their CPK process capability.
No, sir, okay? I can't understand, sir.
So maybe what I will do, I will just give you some example. You're in automotive, right? Right now?
Yeah. Okay. Yeah.
So I'll give a specific example.
Right now we calculate the CPK, sir. Now we calculate CPK only. We will take the 30 number data in any shift. We will check our process. Yes, MS is okay. Then process variation is okay. All is okay, and we will take the 30 number of that part at one time and check the CPK.
Okay.
But then PPK, how can calculate the PPK?
Now, for that particular component, okay, what is the average life cycle of that component?
Average life cycle means
that component when it goes in the automobile, okay, how much time duration that component lasts before it has to be replaced?
Oh, okay, sir. 15 years.
15 years. Okay. So you collect the data of, maybe 10 to 15 years for that component. Okay. That becomes, the long-term process capability index. So if the variation of the short-term sampling is the variation is this, a long-term variation, okay, you calculate this, and then you can compare what is the variation between CPK and PPK.
मतलब means long term means we will take the historical data of that component.
हाँ,
What is the reading is coming of OD? Like as a OD, we will calculate the OD
correct,
CP, calculate
correct.
the CPK
Or a
on
longer
OD.
duration, or a longer duration.
Or longer duration, मतलब 1 year to 15 years, we will
Correct.
take
So
the data. That
just
is
check the
called.
data, how much data you have right now with you.
But
Okay.
how can take the data? Data only 30 number. We will take the 30 number data.
हाँ,
So 1
correct,
year
correct.
only 2 number. 1 year
Right.
only 2 number. 1 से 15 है. 15 में 2 number in each and every year.
So one
That comes
sample,
30 years.
correct. So one sample you have taken, it's a short-term variation. Correct. It's a sample variation. It's a short-term. Correct. So CPK is belonging to the sample. But when it comes to 30, 30, 30, 30, 30, and you have taken that for a month, for 2 months, 3 months, 4 months, 1 year, 2 year, 3 years data, it becomes a long-term variation. Then you calculate the long-term variation. That becomes your PPK. Clear? Yeah. So CPK is a short-term, PPK is a long-term. The long story short, it depends on what time frame will encompass the variability into this. Now, understand this. Another way to putting it this into that is within that time. Let's say you are collecting the data. There should not be any process change. Let's say you're taking 3 years data. Okay. There should not be any major process change within that 3 years data. Let's say there is an automation or there's a machine change you have done. Okay. So that data you should not mix up.
1 minute, but for 1 minute, we will take the 3 years data. But in 3 years, how can take the 30 number of data?
No, you already have that data in your target. आपके पास target, आपके पास record में होगा ना वो data.
हाँ, वही 1 year gas, their component every day produce. Every day that component is produced. We will take the data of every day. We will check the in process check sheet is there, na? Some parameter is there. 5 number per hour. He will check the in process quality person. 5 number.
Correct.
Okay, already. And every day is component running condition. So 1 year, so many data is there, and after 1 year, and after 1 year, 3 years. So how can take the 30 number?
No, so you take that entire 1 year data, na? 1 year, 2 year, 3 year ka data pura le lo.
So not a 30 number. We will take the 200 and
entire complete data le lo. Complete data.
So can we say that we will take the 30 number data that is short term, and we will take the long data and long term like this?
Ideally, that is the thing. But again, the question comes: how do you define long term? That's what my answer is. So short term का आपका clarity simple है. Long term में लोग confuse हो जाते हैं कि is it 1 month my long term or 6 month my long term? Is it 1 year? So you cannot define long term like that. Okay, whatever encompasses.
We can say that long term is depend on the life cycle of that product.
Yes, life cycle also plays a very crucial part in the long term. Yes, see whatever time frame encompasses the variability in that particular component, that basically define the long term process capability. ठीक है?
ओके सर. क्या मैं आपको खामोश हो सकता हूँ सर? क्या एक क्वेश्चन और पूछ सकता हूँ?
अरे बताइए. No, please. I think there is nobody who is. I think people are enjoying our conversation. Go ahead.
Okay. सर एक चीज और जो हम CP और CPK निकालते हैं सर.
हाँ जी.
तो इसमें भी बहुत कंफ्यूजन होता है कि why calculate CP and why calculate CPK? So many times I ask the question at that, but I can't understand sir. CP जब CPK निकाल रहे हैं, क्योंकि मैंने हिस्ट्री पढ़ी इसकी. हिस्ट्री आपकी पढ़ी सर. जब मैंने आपके कहा उसमें हिस्ट्री आपने पढ़ाई है इसकी. CPK ट्रेडिशनल था. CPK में क्या था, एक मैग्नीट्यूड आता था लेकिन डायरेक्शन नहीं आती थी, इसलिए CPK को एलिमिनेट कर दिया गया. CPK का रिप्लेस एक न्यू वर्जन आया. CPK का CP का न्यू वर्जन आया CPK.
करेक्ट.
तो हम CP निकालना बंद हो गया ना. CP फिर पिक्चर में है ही नहीं अब.
Your process keeps on shifting like this. Everybody understands? Correct? If I see our process keeps on shifting. If imagine if our process is not shifting like this, left side, right side, left side, right, then our target and our X bar would be exactly equal to each other. Correct?
Yeah.
Imagine a situation where there is no shift in the mean, in the center में कोई shift नहीं है. But actually, originally it is not possible. Okay, practically it's not possible. You have to have the variation. If there is no shift, that means X bar is equal to target. Then your CP is actually equal to your CPK. There is no difference between CP and CPK. But because there is a shift, and when the process, let's say when the process moves on this side, that means there is more probability of going this side, more defect, right? Okay. So when process moves this side, right? So CP becomes your actual ultimate process capability ka potential. This is your potential. CP meaning your potential. Okay. Why we calculate CP and CPK both? Because CP shows you the potential. Itna aapke paas potential. It's like, I always give this example of cricket match, you know. In cricket match, in 1 over, you can hit 36 runs in 1 over, right? If let's say there is no extra balls deliveries bowled, right? So 36 is your CP. And out of it, let's say you score 20, that's your CPK. Because there will be small amount of variation, right? Small amount of shift from the mean. And because of that mean, either you will shift on left side towards LSL, or you will shift on the right side, which is your USL, and you will make more defects over there. And that's where your process capability will become a little less, right? And that's where your CPK is 20 runs is your CPK and CP is your 36. It is your potential, highest process capability. And our target is to exactly match CPK to CP. That is our target. That's why we always calculate CP and CPK both. CP is the potential of the process, and CPK is your actual, right now, what you are actually performing. That's the difference. Yeah.
That is depend on formula also.
Correct.
CPK USL minus LSL upon 6 sigma.
Yes.
So there is only USL, LSL already defined by customer. That is a band. This is a band of for you.
Correct.
And sigma we will calculate our data and divided by that.
Correct.
That's coming the CP. So CPK defined by the band.
What is the difference between CP and in CP and CPK formula? What is the difference? Only difference is your X bar.
Yeah.
In CP formula, there is no X bar. In CPK formula, there is a X bar because the mean is considered. In the CP, there is no mean considered. That's the only difference.
Okay. So can we say that CP, we will calculate CP for
the potential, the highest potential.
Means what is the variation? How much the variation in the process? That is a target.
Correct.
But actually, what is coming? That is a CPK.
Correct.
But in that case, CPK not greater, never greater than CP. Correct?
Absolutely. So you just do this. Okay. You take multiple data points and sample. You just do this, and you will realize what I'm talking about.
No, sir. 1 minute. That is a thumb rule. CPK never greater than CP. Correct, sir? Correct. So spread of the data, how can defect showing? That defect showing, that is a upper control limit and lower control limit, and data is spread beyond the upper and lower. So that is called the CP. That is CPK, not CP. That is CPK. So here, CP, when you have defects, what is the CP? When you have defects, that is CPK. You're calculating CPK. You put that process in the center. You match your X bar with your target. That becomes your CP. Okay, but CPK beyond the limit. So CP also beyond the limit. Correct? So if CP, let's say for example, let me just remove this quickly. Okay, imagine this is my specification limit. Okay, हम लोग calculate करके देखते हैं. ठीक है? Let's say my LSL and my USL. Okay, now my LSL is, let's say, 40 and my USL is, let's say, 60. Okay, and this is my process like this. Okay. Now what will be and my standard deviation, let's say, is 2. Okay. So let's calculate my CP. CP formula is what? What is the CP formula? USL minus LSL upon 6 sigma. LSL divided by 6 times standard deviation. So we have 60 minus 40 upon 2, 20 upon 2, 10. Upon 2. So it is 12, right? Correct? So which is 20 divided by 12. कितना होता है? 0 point something. Oh, sorry. 1 point. कितना होगा? Everybody just calculate this. Give me the exact number. 1.5. 12 पंजे 60. हाँ. वर्गम 12 नहीं 8 बचेगा. 12 से 84. 1.7. 1.66. So मोटा मोटा. So this is my CP. When my specification limits, exactly my specification limits, this is my target. Okay, so it is not considering where is my mean. All right,
Now, when it will happen, when exactly my mean is matching my center, my CP will become 1.66. Now, imagine my process is shifted on this side. Okay, let's say like this. Correct? Now, this is on this side, my process is making a lot of defects on the lower side. That means my process shifted on the lower side and making a lot of rejection on the lower side. Correct?
Yes.
In this case, my CPK lower will be something like 0.66. Imagine. Okay. Yeah. And my CPK upper would be something like 2. Okay. So I will select CPK lower 0.66 because it is going on the lower side and getting rejected. So my CP is 1.66. So which is my highest potential. My process can achieve 1.66 as my highest potential. But currently, I am only at 0.66. The moment I bring my process back to the center, I will become 1.66 again.
Okay.
And I will save lot of money. जितना rejection हो रहा है उतना सब पैसा मेरा बच जाएगा. I have to immediately bring. So if you bring your CPK equal to CP, your money is saved. Are you clear?
Means, clear, sir. Means we create the two curve now here. One curve is a within the limit and other one is a out of the limit. Correct. Spread of the both limit, both curve is same. 1.66 and 1.66.
Correct. So my standard deviation is exactly same. The process is shifting. See, process shifting does not mean my standard deviation has to shift. Okay, standard deviation भी shift होगा, कम ज्यादा होगा, और process भी shift होगा, दोनों भी shift होंगे. I'm just, for simplicity, I've just kept the standard deviation exactly same and just move the process from one point to another point. And on this side, I'm making more defect. My target as a process owner is to bring the process to the center again and save the money. जितना process को आप center में रखेंगे, CP is equal to CPK. जितना आप center में रखोगे, जितना CPK is equal to CP, you will save money, you will, your profitability will improve. Very simple.
Oh, correct, sir.
ठीक है?
Okay, sir. Thank you.
Super. Okay, good. So guys, all the new members, we will have the recording available in the masterclass archive and you'll enjoy this question answer session, which was, with me and Talib ji. Of course, Talib ji is a very senior person. He has come in the live session after a very long time. Okay. So thank you very much for joining in, guys. We'll connect again on Monday with a new topic. Okay. And tomorrow, send a lot of people, to our yellow belt session on, in the morning. Okay. You'll get the notification to your WhatsApp. You can send it to your colleagues, team members to get your 40% referral bonus. Okay. Okay. Thank you very much for joining in. Keep learning, keep growing. This is Dinesh.